Hi, today I will be teaching you how to graph inequalities on a number line and on a plane. So first, let's talk about what an inequality is. An inequality is a relation that holds between two values when they are different. And they're usually denoted by symbols such as greater than or equal to, less than or equal to, greater than, and less than. So some examples of them are y is greater than or equal to 3x plus 2, y is less than 5x over 3 plus 4, which both of these would be on a plane. X is greater than or equal to 8, 3x is less than 4, and these two would be on a number line. So first, let's look at how to graph equations on a number line. Here we have a sample one. Negative 5 over 3x is greater than negative 20. The first step is to isolate x. Multiply 3 on both sides. That would result in negative 5x is greater than negative 60. And continue isolating x. So divide each side by negative 5. And because you're dividing by a negative on both sides, you have to flip the sign. So it would be x is less than 12. Now let's graph 12 on a number line. Put another number that is in reference to it. So because it is less than, because it is less than, you have to use the open circle to denote that you are not including the value. So let's put an open circle. And because it is less than 12, everything below 12 would count as x. Now let's graph the inequality on a plane. We have y is greater than or equal to 3x plus 4. So before you graph it, it's easy to think of this as a regular equation. Y is equal to 3x plus 4. So when you graph the equation, graph it normally. The y-intercept is 4 and the slope is 3, so it's approximately there. And because it is greater than or equal to, you use a solid line. If it was just greater than or just equal to, you would use a dashed line to indicate the value. And now, to know whether or not the values are below or above the line, you usually use a test point. And in this case, we can use the test point 0, 0. So let's test it out. 0 is greater than or equal to 3 times 0 plus 4. 0 is greater than or equal to 4. Because this is not true, we know that these values below the line are not true. So you can shade everything above the line. That's how you do this problem. So another example we're going to do is on a number line. We have 15x is less than or equal to 45, and as I said previously, we have to first isolate x. We would get x is less than or equal to 3. And now we plot 3 on the number line. So now that 3 is one of the values that x could be, we denote it with a closed circle. And because it's x is less than or equal to 3, everything below 3 is a value, so you can shade it in. For our fourth equation, we have y is less than 1/2 x. And when you graph this equation, as I said before, treat this as a regular equation, y equals 1/2 x. So this equation passes through the origin, 0, 0, and has a slope of 1/2. However, since this is a y is less than 1/2 function, you use a dashed line to indicate the line. Then use a test point to test whether or not it's above the line or below the line. So let's use the test point 3, 0. So 0 is less than 3 over 2. Because this is correct, we know that the answers lie beneath the line. So you just shade the region below the line. And that's how you do this problem.